Hi everyone, Frankie from easypowerwall.com. In previous video I showed you the full tour of the powerwall station. This week is about this small board, the BMS protection board. We already talked about the batteries, the BMS. Well, this board is in between the BMS and the batteries. This is a safety feature. It's not really needed, but if you work with this kind of installation, this kind of power, safety is very important. That's why I added this BMS protection board. So I show you how I designed it, how I built it, and how it's implemented in the Powerwall. Of course, all documentation will be shared, Gerber files like that. You can download it. The link is available in the description. Enjoy the movie. If you have questions, don't hesitate. Use the comment box below. I'll try to help. You can start building this board before you have the cells. So did I. Started developing from scratch using KiCad and really liked the challenge to pick up and designing PCBs after 25 years. The first PCB based on SMD fuses was fine, but soldering these small fuses was a pain in the butt. Working with a heat gun was a new skill too. It worked fine and I really liked the results. Hence I used the SMD PCB for a few months in the system. At the end, I really like to go the KISS route. Keep it stupid simple. Or does the double S stand for simple and safe? When designing and engineering, I keep in mind that everyone with basic skills should be able to build the product. I went back to the engineering room and started a THT or through-hole technology version. After all, I really liked the looks too. Assembling and soldering is done in minutes. Access for testing and maintenance is much easier too. This week the postman brought a few new packages in. Our corporate sponsor JK PCB and some more packages from AliExpress. I'm pretty happy with this solution. But for people who don't have a heat gun and really want to use the through-hole technology, I made a third solution. And this is the PCB. As always, the quality we expect from JK PCB, very nice. So what's the purpose of the board? The same purpose. Here we have the SMD fuse, and these are the normal glass fuses we can install the socket on the PCB board, then enter the fuse, and here we mount the Phoenix connector, just like this. I think this might be a very neat solution. Okay, let's give it a try. The fuses are rated for 3 amps. The balancer is only 1 amp, so this should be enough. It's just to prevent from a dead short. And maybe if I ever want to upgrade to a 2 amp version, then I'm still okay with this 3 amp fuse.
Maybe I should check first if it electrical wise is well connected, but I have no doubts it will be working fine. Nice. Yeah. So guys, what do you think of this solution? Do you go for this one over the SMD socket? Please write your comments. Honestly, I'm a huge fan of this solution. It looks more solid, it's very symmetrical. Yeah, I think it's very nice. Just have to wait for the Phoenix connectors, they're in the mail. So I forgot to record the soldering, but of course, you've all done this before. This is the final result. I'm a bit surprised by the length of the BMS leads. They're close to 1 meter, so very, very long. I think I will shorten them but let's see. Let's first connect the BMS. I will most probably make a loop like this behind the BMS and then connect it this way. To the BMS. I got the balance leads for a 20S version. Of course, I'm using only 16S, so I can remove these balance lines that I don't need. It's very simple. You need tweezers you use for SMD soldering or just something very sharp. You press hard and it comes loose. This one needs the most positive voltage from your pack. So make sure you keep this one. I think on this side I have a special holder which I can glue on the BMS, and then it goes upwards and I can connect it to the BMS protection board. Another great tool to remove the insulation of these thin cables. If you have to do it with a conventional stripper, it's more difficult, but this one gets it always right. And you don't have to adjust it, so it's easy. So I'll start connecting the wires from the BMS leads. So I'll start with the ground. So take your time, this really has to be perfect, if not you will have serious issues, maybe hardware failures. So take your time and make sure they're properly connected. So tighten the screws, but don't over tighten, it's not necessary. So we have the first 10 wires connected. And now we continue with connector number 2. That's the one. The only thing that's left to do is to connect the wires from the batteries. I have all the wires here, and now I want to protect them via this BMS protection board. I had to remove a part of the PCB because these connectors wouldn't fit, but of course I will update the PCB design that I'll share via a link you can find here below. Ground is the most negative, and then I'll start adding all the other wires to the BMS board. How do I find the most negative wire? It's just by checking the voltage of the wires. When I find the 0 voltage, this is 16, 23, so after number 3 is 3 volts. I have a 0. So number 6 is 0 volt. So I remove this wire, and this is the most negative wire, or the ground, and I'll connect it to this connector. So let's start doing this. Again, using my magic tool here. Links to all hardware, connectors, fuses like this, you'll all find it in the description and on my website easypowerwall.com. I remember number 3 was 3 volts, so that must be the first battery. But it's very important, check and double check this step, because you don't want to make any mistake here. So we have the 0 and the 3 volts. Now let's check for the 6 volt. Here we have the 6 volt, that's number 4. So we can find number 9 as well. So I won't film or tape record the whole process, but this is how you work your way up till you reach the last one from cell number 16 where you hit the 52 volts. I just finished connector 1. That's 10 connections, so let's check if the voltages are correct. This is ground, should be 0 volts. Yeah, 0, 3, 6, now close to 10 volts, 13, 16, close to 20, 23, 26, and now close to 30 volts. Yeah, that's right. So they're all on the correct order. Take your time, check, double check you, and make sure they're in the right order. So we ended here with 30 volts. So now I have to look for the 33 volt. So I start continuing doing the same job as I did with the previous connector, work my way up to 52 volts. Make sure all copper strands are in the connector. This one is the next one for 33. This is cable 52. I mentioned it before. We have 18 connections and I will use number 18 to feed the BMS with the most possible voltage. This is not recommended, it's obliged, otherwise the BMS will not function. So I hope it fits properly. To add this connector too, but I'll give it a try. It seems to work. Oh yeah, it works. I have the 52 volts. Before I connect the connectors to the BMS protection board, I'll check once more the voltages. So ground is 0, 3.3, 6.6, now 49er, 52, and the last one should be 52 as well. Yeah, that's correct. This is the situation right now. Of course, I'll put something under the PCB board so it's installed like this, and I'll put a sleeve around these cables so it's neat and tidy. Now it's time for the more challenging part. We need to get these cables in the sleeve. I think the sleeve is a bit too tight for the cables. I made an assumption of using smaller wires, so I might replace these in the future with a larger type. See, you need to fiddle, but at the end the wires go in the sleeve. And the result looks amazing. It's much neater than all these loose cables. And it gives a high quality touch to your project. Time to fix the BMS protection board on its final location. I'm going to use this hardware. It's self-adhesive tape underneath. So won't move anywhere. Nice. Yeah, I'm happy with the result. Before installing the BMS and fix it on its location, I'll get something else out of my magic box here with all my parts and tools I use to make the powerwall. It's this. This is used to hold the wires together on the BMS. It's self-adhesive, so I'll stick it on the BMS. So this way it allows me to pull back or use some extra length to connect it to the BMS board. So now this is done. The only item I have to install is the on-off switch. I'll check if once the BMS is activated, if it's still needed, then I'll leave it attached, but maybe it's not really needed, and then I'll most probably remove it.
Wow, you kept watching after 27 minutes, thank you. I won't keep it long. But for next week, we will fire up the JK BMS. I'll press this magic button and see how it comes alive. I will also go over all the settings of this BMS. So very promising video next week. For now, check the information below the video, where you find additional info, links to hardware and tools, and so on. If you have questions, use the comments. See you soon.